So we've got a cube. I'll do my best to draw with what I have here. Here's one side. And these dots mean we're behind that face. Okay, it's not the greatest, but there's our cube. The side of the cube increases at a rate of 1/5 meters per second. So the cube's volume is determined by the side being squared, right? Cubed, sorry, well, cubed. It's length times width times height. And it's a cube, so all the lengths, the widths, the heights are all the same. So that's the volume. So the side of the cube is increasing. So that means the side of the cube, they're talking about the rate of change of the side of the cube. So the derivative. The derivative is equal to a positive 1/5 because it's increasing. And then we're supposed to find the rate in meters cubed per second. So that's a volume derivative, in which the volume of the cube increases when the side of the cube is at 5 meters. So we need a formula to find out the rate of change of the volume of the cube. So we need to take a derivative of this. It's with respect to time. We don't know what this is with respect to time. Actually, it's confusing because I've got s as the side of the cube. So maybe we'll make this x, because s is going on behind the scenes. Seconds are going on behind the scenes. So x is the side of my cube now. And x depends on s. X depends on the number of seconds that have elapsed. So if I take this derivative, that's going to be 3x squared times x prime because of the chain rule. Okay, the derivative of the outermost function, it's an exponential, it's a power function. So the 3 comes down, multiplies, and the power gets reduced by 1. But the derivative of the innermost function isn't just 1, because we're taking a derivative with respect to s, with respect to the number of seconds. So this is our rate of change of volume formula. So we can solve for volume now. If we plug in the information that we were given that x prime is 1/5, and we're given that x at the side of the cube is at 5 meters. So the side of the cube is at 5 meters. We're plugging in 5 in for x. And then if you simplify that, that should be 15. So it looks like 15 meters cubed per second is how fast it's changing.